All right. Can you guys hear me good, by the way? Can I get a couple thumbs up maybe that you can hear me okay? Great. All right, perfect. So good to see you guys again. So if we're starting with 30 pints, okay, there's a lot of ways you can do this. And in my experience, and if you took chemistry in high school, this will be somewhat familiar. We're going to start with the given measurement, and then we're going to multiply by different things to get us 2 gallons. Okay, so what we need to use is we need to somehow relate gallons with pints. Okay, so if you see that little salmon box there, we don't have something that just says like gallons equal pints given to us. So we kind of have to make it there. You can think about it logically as like, okay, if 4 quarts is 1 gallon and there's 2 pints in 1 quart, you could be like, okay, 2, 2, 2, and 2 make 8. That's totally fair game. But I'm going to do it in a way that's a little bit more formal for when it gets more complicated here. So what a lot of people do is they actually write this as a fraction as 30 over 1. And then the whole thing, this is called dimensional analysis, and it's how you get the dimensions, the pints, to turn into gallons. If you remember something like if we had like 2 over 3 times 4 over 2, you remember those 2's can cancel out if one's on top and one's in bottom. And we're going to do that same exact thing with the units here. So what I know about pints is that there are 2 pints for every 1 quart. Okay. And again, the reason why I'm allowed to do this in blue right here is because 1 quart divided by 2 pints is technically just 1, because they're exact same thing. Anytime you have the same thing, like a 6 over a 6, that's equal to 1. The same thing is true. 1 quart over 2 pints is just a fancy version of 1. That's why we're allowed to write it like that. As you can see, these pints, one's on top, one's on bottom, so those cancel out. And I'm left with just a quart here. Okay, but I want gallons, so I've actually got to do one more here. I'm going to do it in green. I need to now involve gallons of some kind with quarts. So that's what that bottom line of the salmon is that are going to be. And I'm going to draw my fraction. And there are 4 quarts for every 1 gallon. Again, the reason why quarts is in the bottom is because I want the quarts to cancel each other out. So I'm going to cross out, cross out. And so now all I've got is a gallon. And now I just need to multiply the numbers like normal. Okay. So if I multiply the cross at the top, I get 30 all divided by 2. And then I've got my gallons. Everything else canceled out. And 30 divided by 2 gallons is 15 gallons. Again, that probably feels super formal. And it's because it kind of is. You could have just, you can think about it logically, like we said, if you want. But again, if this process comes a little bit normal, it'll get great. So there's a similar example here. This is actually taken from your exam sheet. I'll do a friendly reminder of the exam sheet, which is posted for you on all the exams. This won't show up on an exam for a little while since it's unit 4, but still good to know. All that stuff at the top there is kind of what we're working with tonight. Okay, basically the top half of your reference sheet. So if you've been like, this reference sheet isn't helpful, it will be on this next one. So basically it's just looking at different prefixes and just basically what each one means. So you can kind of read that if you want. Kilo is the most common with 1,000 that we use. And then deci or centi or milli, those ones are kind of more common to us as well. Okay. And so now if we convert this, just like we did before, we're curious how many gallons are there in 5 liters. So again, we're going from liters excuse my crappy handwriting. We're going from liters to gallons. Okay, so we've got to relate different things. We got to get rid of liters and turn it into gallons. So I'm going to start this just like before as 5 liters on top, all divided by 1. And now remember, there's not one specific way to get there. So you kind of want to just use whatever you can. If you're doing this like with any of your friends or whatever, you might do it differently and you can get the same answer. I'm going to try to use liters as soon as possible so that it goes away. So what do I know about liters and gallons? Well, I don't really know anything. If I look at the sheet up here, liters and gallons isn't up there, but there is gallons and quarts. And there's also liters and quarts. So hopefully you're kind of starting to see a relationship there. I'm probably going to use the liters and quarts as well as the quarts and gallons. So my idea at the beginning, what I just said, I can't really use gallons yet. I can use liters though. I can write this as liters and quarts based off of that box right there. So I've got 1 liter. Again, I'm putting that in the bottom because the original liters on top and those are going to cancel. And I'm going to put my 1.06 quarts on top. Okay. Again, I'll cancel out the liters in another color. And again, if we're trying to get from liters to gallons, currently all I have is quarts. So what I have to bring in now is another blue fraction. I'm going to say that there are 4 quarts in 1 gallon. Again, the reason why the gallon is on top is because that's what I want to end up with. And the reason why the quarts is in the bottom is so that it cancels out with the other quarts over here. So all I'm left to do here, oh, my microphone changed, excuse me. Okay, great. The only unit left is gallons. The denominator is 1, 1, and 4, so that just stays as a 4. Again, sometimes people want to call that a 6, but make sure you multiply. And then when I multiply 1.06 times 5, I get 5.3. So to actually get my final answers in gallon, I'll divide 5.3 and 4, and I get 1.325 gallons. Okay. So if we had to answer the question, there are 1.325 gallons in 5 liters. So again, we are not going to cover 8.1 tonight, which is kind of the introduction of this. But basically 8.1 is what we just did with question 1 and question 2. Those are basically warm-ups to get us to see what's coming up next. Okay. We're going to use the same concept below. Again, there's lots of ways to do this. If you find a better way, do it. This is just the way that makes the most sense in my brain. I want you to see the main difference here. So it says we've got a 60-inch widescreen TV, and it has an area of 1,546 inches squared. Now, make sure you notice that there's that little 2 there. That's not just there for fun. It'll be there. It'll be important as we see it, as we come up next. How many square feet is that round to the nearest 100? So I'm going to go from inches squared to feet squared. Now I'm going to write this in a kind of a weird way that you would never actually write it down, but I'm trying to just make a point here that inches squared is the same thing as inches times inches. And feet squared is the same thing as feet times feet. The reason why this is different from the previous question is because it wouldn't have been, but if it was 5 liters squared, So if I do this in purple, don't copy this down because it will not be right. If you have 5 liters squared, which you wouldn't because that doesn't make sense like mathematically. And then you only had 1 liter on the bottom, you only have 1 liter and then 2 liters on top. So you would have to have some version of liters squared in the bottom for that to actually cancel. So that's going to be the main difference between what we just did and what we're doing now. So we've got 1,546 inches squared. I'm going to put that all over 1. And I'm going to turn that into feet. We know that there is 1 foot for every 12 inches. Sorry, I almost said 1 to 1. Okay. But notice you've got this little 2 here. Notice that 2. Okay. So the purple fraction is not enough on its own. You actually need a second purple fraction of 1 foot for every 12 inches, because now you've got inches on the bottom and then inches on top that will then cancel out. Okay, so again, try to see the difference between question 2 and question 3. In question 2, there was no squaring. Question 3, now that there is squaring involved here. Okay, that's the main difference. So from here, those inches are all going to cancel out, cancel. And you're left with 1,546 feet squared, all divided by 144 because of the 12 times 12. So when you divide those, you're ending up with 10.74 feet squared. Again, the reason why this is weird this time is because it's area. And when we measure the area of things, we have to square it. Okay. So when you're dealing with area, you're going to have that extra unit involved there. So I'm trying to think of if I want to stay consistent, I'm going to solve number 4 like we did with number 3. You could convert this to meters right now, but then you would have to do the dimensional analysis twice. And so I would rather just find the area first and then convert. Okay, so whatever random unit you're given, I personally would find the area first and then convert it using the process like in number 3. So the actual area is going to be 400 times 700 because of length times width, which that's going to be 28,000. Actually, a lot bigger, 280,000. Sorry. Yeah, 4 zeros. And that's going to be centimeters squared. Again, it's centimeters squared because there was 400 centimeters, 700 centimeters, 2 of them. So it's squared. So I've got my area. Now I need to convert that thing to meters. So I'm going to put it over 1. Can you guys hear me? Some people are saying they can't hear me. Sorry, we can't. Can people hear me? I think people can hear me. Okay. Megan, maybe you could try to mess with your audio settings for a sec in the corner, maybe. That's what I would do. Can't find your face on here. Okay. So converting that, we want to do, I believe, according to our chart up here, there are, or you can use the You can kind of do it however you want. We're looking at that centimeters and meters. There's 100 centimeters in every meter. Okay. So if there's 100 centimeters, that's going to go on the bottom because of the centimeters that was on top before. I'm going to put my 1 meter on top. Again, the red will not be enough to cancel out the purple centimeters squared. So I will need a second one in order to actually cancel that out. So those centimeters units are now gone. And since I have a meter on top and another meter on top, that's going to give me meters squared. So the actual work that's going to happen is 280,000 divided by 10,000. And using my calculator, or you can cross out the zeros, I believe you're left with just a 28 meters squared. Again, the reason why I did it that way, where you found the area then converted, is because you're going to have to do that process a lot. So we might as well just get better at that process. But again, you totally could have converted 400 and 700 to meters first, and then found the area from there. So the second part says you want to build a new deck that's the same size as your current deck. If you already have 300 square feet of boards, would you have enough? So essentially, we're given square feet, and we're curious, is that bigger or smaller than 28 meters squared? So I should probably I can either convert the 28 meters squared into square feet, or I can take my 300 square feet and convert it into meters and just see if it's bigger or smaller. So I'm going to go ahead and just do that. I believe you're given the metric conversion. Why am I goofing up here? So that's kind of frustrating. You're given the inches to centimeters, and you have feet and meters. So there's some kind of goofing around here we're going to have to do. We should probably convert this to inches first. So for every 1 foot, again, that'll be in the bottom, there's 12 inches. Again, that blue will not be enough. I need a second one because of the squared. But now I'm in inches. So I can either take that, I can go all the way to meters if I want, or I can just go to centimeters squared since I know it's 280,000. Either way really works. I'm going to use what's in our chart, in our formula sheet, that it's 1 inch for every 2.54 centimeters. So for every 1 inch, it's 2.54 centimeters. And again, I will need 2 of those light blues because everything is squared. And so now all those inches are gone. Inches, 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 inches. And so now I believe I'm going to have a centimeter squared when I multiply that all out on top. And I can just compare it to the 280,000 before we converted it to 28 meters squared. So when I multiply all that out, I get 278709.12 centimeters squared. Which the question is 300 square feet enough to build the deck? And so since our answer is smaller, we do not have enough. Okay. We will not have enough to do our deck, unfortunately. We've got two more questions, and then that'll take us to our first break. So again, the goal is to get through 8.2 and 8.3, review a little bit together, and then I'll give people the freedom to leave if they want, and then we can keep reviewing to finish out. If you don't get that copied, remember there is similar notes in the folder. I always attach the key for you guys just because it's nice to have. So great. A little bit of thinking here. So she's getting some new carpet and she sees that her room is 17 by 20 feet. And she found a carpet option that she likes. One carpet is 21 per square yard, and the other is $2.50 per square foot. How much, if she goes with the cheaper route, how much will it cost to have the room carpeted? So you got to figure out which one is cheaper, it looks like. And then you need to figure out how much it would actually cost to use that cheaper one. So really you can either go from yards squared to square feet or feet squared, or you can do feet squared to yards squared. I'm just going to start with 21 yards squared and just kind of see what happens from there. So I'm going to put that over 1. And we are aware, according to our chart, that there is 3 feet up in the top left, 3 feet for every 1 yard. Again, I need 2 of those to get rid of the yard squared. And so that will give me 9 times 21. Which is 189. Oh man. I goofed that up. That's my bad. Sorry about that. That per, I missed the per. That's my bad. So really the fraction bar acts as a per right there. So to do the least amount of erasing, sorry. So we've got $21 here. I was like, that number does not make sense. We've got $21 per 1 yard squared. So if I leave it like it is, I'm going to have all yards in the bottom, which is not good. So I've got to flip my red ones around. Again, I apologize. I really hate erasing as a student. So I know it's annoying. Not that that makes you feel better, but just know that I know it's annoying. Okay, so we've got yard squared canceling out. So I'm going to have $21 per 9 feet squared. Okay. So when I divide those out, I get $2.33 per 1 foot squared. And so it looks like that is cheaper because the other one was $2.50 per 1 foot squared is what I'm seeing there. So the cheaper one is what we did in blue. So we got to figure out how much is it going to cost to have that room carpeted. The area of that room is 340 feet squared. And so I believe if we take our $2.33 per feet squared, and we multiply that by 340 feet squared, we're going to be left with just the dollars, which is all we want. And so when I multiply all that out, I get $792.2. If you didn't round, like this is 0.3 repeating forever. So if you didn't round, your number might be a little different, but we're going to say that it was $2.33. So we get 792.2. I think that's a little different than the answer key. Yeah, the answer key did not round. It left it as like 333 repeating. So essentially it took that decimal and multiplied it by 340. But here, either one is acceptable. Okay, last one, and then we'll take our first break. So if you've got like normal base units, then you have area, which the main thing you needed to see about area is that it was squared. Volume, which is what we're about to do right now, is to the third power. Okay. So if we've got this in-ground pool, volume comes from length times width times height. So our volume is going to come from that 3 times 7 times 2. So that volume is going to be 42 yards to the third power this time because I'm multiplying 3 things together. So if we're given 42 yards to the third power, all divided by 1, I now have to do 3 feet for every 1 yard, 3 feet for every 1 yard, and 3 feet for every 1 yard. Okay. So again, we've got yard to the third, yard, yard, yard. So you're left with feet to the third power, ending up with 1,134 feet to the third power, or feet cubed. So that's our volume. So if we've got an algae problem and we've got an 8-ounce bottle that treats 350 feet of volume, how many bottles must be purchased to treat this water? Okay. So I think we can just take our volume, however much is in the pool, and divide it by however much we can get with each bottle. And that'll be pretty telling of how many bottles we should need. So a lot of times people struggle here. Really, if I wanted to do the work, I could have done, if I do a new color, I could have done 1134 times 1 bottle per 350 feet to the third power. That works as well because it's 1 bottle per 350. Again, that per situation gives us the fraction bar. The purple is like more like the nerdy way. Like most people aren't going to actually do the purple way. The red way is going to be like if you're sitting at the store trying to figure out how many bottles you need, you're going to probably do the red way. So again, your answer needs to be that you need 4 bottles though, because 3 will not be enough. Because you need some of that 4th bottle. You're not going to finish it, but you need some of the 4th. Okay, last one here. If they cost $5.79, how much will he have to pay for the allergy side? So you just take those 4 bottles, multiply them by $5.79, giving you $23.16.